So today's talk, let's see if we can get the presentation console to work. So today's talk is really framed around sort of the lessons that we've learned from doing this sort of work as a technology company in scientific research and some of the parallels that we can draw to big business and also industry. I come from a company called Digital Science. We are a technology company, a relatively new one as well. Today's actually sort of our one-year birthday, and I'll give you a little bit more of an idea as to where we came from and what our mission is. But our background as a technology company actually came from publication. So our sister company, for those of you that may work in the sciences or are well read in the sciences, our sister company is Nature, one of the leading scientific journals. Our parent company is also a global publishing entity called Macmillan. We're the first non-content oriented thing that Macmillan has ever done. And it was really created with this sort of understanding of how we can actually serve the needs of the research community and really use technology to unlock some of the potential when it comes to accelerating discovery, understanding disease, and really enabling better scientific research and research in general. So we are a full-on sort of separate entity that is really the first sort of step for Macmillan as an information company into this space. And we wear a number of different hats. We serve as a technology company at our core. So there is internal software development. We spin out products in a number of different areas, really trying to make it easier for researchers and research administrators to do their work. And I'll explain a little bit more about why this is important and what our spin is on this. But we also we're created with this idea that reinventing the wheel is often a really poor use of time. So we do serve as an incubator and have an investment arm to help bring other startups and businesses under the fold that are already pushing the ball forward when it comes to developing tools to help make research a little bit easier for our communities. So we do have this bit of hybrid approach, which really sets us apart. But really what we know is research. That's the community that we serve. That's where most of us come from internally. It's who we know. At the same time, we're also technologists. My background is in scientific research. I used to manage the science wing of an organization called Creative Commons, where we really looked at how you can actually try to address some of the roadblocks that are keeping research from moving as quickly as it possibly could and doing as much as they can. So as technologists, we do develop tools, but it is focused on this community here. The focus of today's talk, though, is a little bit different. So there are a number of different lessons and takeaways on the higher level from how we're coping with the move to digital in the research world from academic institutions and labs on that side, but also when it kind of moves out to big business and industry, of the different sort of information inputs that we're now facing and the scale and complexity. And really still looking at some of the breaks in the system, and there's plenty of them. So today's talk will look at some of the lessons that can possibly be learned from this and applied to the other areas that we're talking about today and sort of the broader research enterprise, and give you some anecdotes for that as well. But really starting with how the web has transformed the way that we approach research, whether you're in a lab at an institution or beyond. It has affected the research workflow in a number of different ways, how we even think of the processes and how we address doing our day-to-day and utilizing expertise, the technology that we use for analysis, for aggregation, for distribution of information, issues of scale and complexity, which I'll go into a little bit more. Even just the mediums that we're dealing with. It's not just the kind of static web pages anymore, as the previous speakers have sort of gotten at. It's the analytics, it's also the underlying information, or even the mix of analog and digital content. It also has really affected how we do knowledge discovery and the barriers that come with that. But in the research world, and apologies if this is something that many of you have seen before, we are faced with the kind of static research cycle, the broad sort of understanding of how this has worked for hundreds of years, of having your breakthrough idea, the light bulb going off over your head, then going through, doing your literature review, seeing what's already been published or done in that area, acquiring your materials. In some cases, that's actually static materials. In others, that's code and a number of other different things that could possibly fit into that bucket. Doing your experimentation, analyzing your information, hopefully sharing those results, and really trying to build upon what you've done thus far. But there's increasing sort of blocking points in the system, whether they're due to financial constraints, which we're finding when it comes to accessing content, depending on where you are in the world or which institution you may be at. You may not have the same access to the content, the really sort of well-curated content. It also can be a technical constraint as well. You know, how you even attain your materials is something that has, you know, led to quite a lot of waste financially, and also waste in time, which for a scientific researcher is often the most precious commodity that you can have. And even how we do analysis. So there's been a number of speakers today that have talked about some of the advances that we've made in this space, but you know, the tools are still being matured as we learn a bit better how to navigate this space. And getting to the information sources or the mediums that we're dealing with here. You know, we're not just looking at, you know, the content anymore. There's also the physical materials. In the research context, this could be cell lines. These could be DNA snippets or plasmids. These could be sparkle endpoints. This could be how you're doing your query, or even the negative data that you're collecting as a result of your research. And I'll be speaking more about sort of the importance of negative data at Strata in February in Santa Clara. But these are really different things that we are not accustomed, our systems are not accustomed to handling, and also our understanding, the way that we are used to doing research. Much of it comes down to the entrenched norms and the practices that have been passed down from generation to generation, from work experience to work experience. And so these things start to play into our character and how we even think of information and what sort of digital footprint it may have. But getting to some of the lessons that are moving beyond sort of just the academic research enterprise and also having a role in big business and industry, we are facing an increase in scale and in complexity of information. Take, for example, this is an image that many of you may have seen from the Economist article on the data deluge. But the amounts of data, even in various research disciplines, is going to become completely unwieldy. So this year, the 30-plus terabytes nightly, the Large Synoptic Survey Telescope, a new telescope that's being created as we speak in Chile, that's slated for 2014 or 2019, it will hold the world's largest digital camera. If you can even think of it, 3.2 billion pixels and aimed at the sky, capturing an area 49 times as large as the moon in each 15-second exposure. It'll do that 2,000 times a night if this goes off as planned. That leads to about 30-plus terabytes nightly, which brings us into the age of petascale astronomy. Now, not all of our tools at Digital Science are actually focused on this amount of information. There are systemic management issues, even if you're just dealing in gigabytes. But just to show that these are plaguing other areas of research and enterprise, and it really presents a sifting problem. So take, for example, as a usual sort of Google search, and I'm not expecting you to actually really understand or care actually about the thing that's typed in there for the strain. But this is still very much the starting point when you're looking at doing your research to see what's already been out there, whether they're news articles or scholarly literature. And what this is here, if you really want to know, it's a chemical compound. It's kind of a tricyclic antidepressant. It's similar to diazepam, if any of you have used that pharmaceutical. But this is still the way that most researchers, even when they're doing drug discovery, where they've got very sophisticated tools in pharma and also in institutional labs, this is usually their first point. Now, sifting through 1.5 million results, most of it being irrelevant, is just not a productive use of your time, and it doesn't really get you to where you need to go. Looking at sort of subject-based repositories or databases, this here being the USPTO website, This is actually a recent snapshot. It sort of looks like you're working in the past. In this case, is often worse, and especially when you're looking at patents for drug discovery to see if you can even develop in an area, they're designed to be intentionally confusing and be a roadblock in and of themselves. So you can see how these problems start to be exacerbated. Now there are ways and there are technologies that really can sort of streamline this process to kind of tune in to how chemists think. They don't normally think in those really long, clunky strains, and just like many other areas of research, whether you're in bioinformatics or in manufacturing, there are often more than one name for a certain entity. I mean, we are humans after all. We like to put our own creative spin on them. So the issue here can be quite problematic, even when you're looking at chemical compounds that you think would kind of increase in sort of it's fine, or be able to be fine-tuned as it gets longer, but it doesn't actually happen. So there are technologies that allow you to actually search the way that chemists think. This is one called SureChem, and it allows you to sift through that same literature by actually just drawing a chemical structure, which can show how you can put a different spin on that. And that's just sort of the beginning of where you can actually pair sort of the natural language processing and text mining to move a little bit further. But even just in terms of man or machine power, I mean, looking back at the example in astronomy, even with all of the advances that that field has done and the press that it's gotten when it comes to crowdsourcing and the benefits of kind of engaging citizen scientists and the broader community to help solve really difficult problems and to sift through information, that's even pushing the limits, of what that can really wield from that. So if we don't start to have the proper sort of technologies and also just the expertise and understanding, we will get swallowed by this information, and it'll be a huge opportunity cost. Also, moving on, our mediums are evolving. So I touched on this a little bit earlier, but in the research enterprise, we're still dealing with a mix of digital and analog mediums. So these here are lab notebooks. There's an effort to at least digitize them in some sort of way, but we are still looking at a lot of non-digital materials. So, which freezer your material may be in, what sort of plate and what experiment may be going on. These are all information sources that are being handled really poorly when it comes to the lab in a matter of sort of Excel spreadsheets, Post-it notes, and usually a color-coded stickering system. With all the technologies that we have, it's just not acceptable, and it's just not scalable. Even ordering and processing information, details that would never really be something that an individual researcher, whether they're a postdoc or a principal investigator, would normally care about. It would be something that the lab manager would have to deal with. But these are really important things to understand the broader way that research is going on. And so when it comes down to the protocols or the recipes, the way that you actually go through and conduct your experiment, the miscellaneous literature, all of this is sort of falling through the cracks. Even the tracking and the expiration information for various materials, which often can be extraordinarily difficult to attain and to actually acquire in a reasonable time frame, only to not necessarily mark down when that is going to expire in your fridge and to lose it altogether. So these issues are starting to find, there's different ways now to actually take things that are mostly analog but do have digital footprints. Take some of the lessons that we've learned from how Google, eBay, and Amazon work together so that we can have better e-commerce platforms, and try to take some of those lessons and apply them to scientific research so that we can minimize some of the work here. But we're also facing a perception issue when it comes to our understanding what sort of information we're dealing with, how we actually view information in this space. In the research enterprise, we still put a lot of credit and a lot of faith in the scholarly paper, but there are a number of other components, whether they're the data sets that supplement that finding or are backing that finding, the biological materials that may be linked to that research if you're talking about something in biomed, the code if it comes to being able to execute on that. And that's not maintained in the same sort of way. It's not valued in the same sort of way. So really understanding how information should be treated and preserved and accessed, how it should be made available for future use. Alistair's comment about how we view big data, storing the information that we may not know how we're going to use yet. That's still a huge hurdle when it comes to scientific research, because there's a lot of issues when it comes to what is valued and what's seen as junk data, a classification I really do not like. So we need to be comfortable with being measured, as Diego said before, and scientific research is no exception to this. But we also need to make sure that we're not just extending the walled gardens that we've become really accustomed to creating over the last set of hundreds of years. And when it comes to doing research in these sort of ways, due to some of the social aspects of it all, about how we're actually measured, how science is rewarded, and how competitive this can be, regardless of sort of the financial incentive, but just based on human reputation and how we behave, it can lead to a lot of locking up of information instead of making it more available and really putting our technologies to the test and also our minds. We're still locked in old mechanisms. If you are based in the scientific research world, you are very, very familiar with how science is measured based on citation and impact factor, something that Eugene Garfield based off some writing by Vannevar Bush back in 1945 when he founded the Institute for Scientific Information, the first sort of entrance that we had when it came to impact factor back in 1955. It served us well in the research enterprise, but it is a very heuristic mechanism of measuring research, and it is based on papers, and it's based on the relationships that you have with others, not always how reproducible your science may be, and all these other things, or what other components may be involved. So being locked in the old mechanisms actually is providing a disincentive for others to value information in new ways, to really put the time and the effort into curating their data set, to putting the metadata there so that it can enable better discovery down the road, to making their code available for others to see so that they can build upon it. Things that really are at the base of what science should be all about and what research is all about, of building upon discovery, but making it much more difficult as a consequence. So a few examples, not to be too much doom and gloom in this. There are some examples, especially sort of in industry, where groups are pushing this a little bit forward. And for this, looking at big pharma, in terms of making information available, GlaxoSmithKline a few years ago, when I was still working at Creative Commons, made available in the public domain almost 14,000 compounds known to be active against malaria, along with other pharmacological data that could really help enrich that data set when it came to solubility, absorption, metabolism, things that are really important to helping how we understand disease. Eli Lilly, back this past September, put out an open source drug discovery platform that, yes, is designated to help feed their company's pipeline, but also has a philanthropic purpose when it looks at how to bridge efforts with external researchers and those that are engaged in studying tuberculosis. In this case, it's a certain type of drug-resistant tuberculosis, and working with other disease agencies to help try to make some advances in the field, instead of just keeping and perpetuating the same silos. The Pastoria Alliance also is a group that it was formed back in 2009 by a number of the top pharma giants, from AstraZeneca to GSK, Novartis, and Pfizer, realizing that their organizations were all individually siloed and hitting the same problems while doing pre-competitive research and looking at ways of moving beyond. But resource constraints can have silver linings. Financial constraints can cause us to think about these problems in new ways and looking at how we can maximize return on investment, whether in big pharma, manufacturing plants, or an academic research lab. We're now faced with doing more with less, but still retaining our competitive edge and spurring innovation and development. We also need to plan for the non-technical challenges. As I said before, time is the most precious commodity for a researcher. So we can have the slickest bit of technology, but if it doesn't show immediate value and if it doesn't play to that problem, so that it saves them time or doesn't present any other roadblock, we'll be losing in the game. So just to close, it's really difficult to future-proof, whether it's a research enterprise in this context or in a broader sort of industry context. It's really difficult to future-proof how this information could be used down the road. And in the scientific research world, it's even harder to make that case to others of why it's important to save data and how this could be a benefit down the road. Design decisions are key. Flexible, scalable, and robust systems are needed to withstand the information that we have now, but also the content and undoubtedly the challenges we're set to face in the future. The World Wide Web flourished in the face of competing services such as Prodigy and AOL due to these sort of design decisions. So making sure that we have in mind always the various constraints and their flavors to make sure that we're making the most of these technologies and network effects. And leading off of this, remember that we're building tools and engaging in this space for humans. So I like to think of it as software development for the irrational. There are always going to be entrenched practices of the human that cannot necessarily be solved by pouring technology over them. So just a few things to keep in mind, and I look forward to the rest of the talks. Please feel free to get in touch if you'd like, and I look forward to the rest of the seminar.
All right, Caitlin, lots to think about. Thank you very much. I remember hearing someone talk about the collectors at CERN and the black hole simulation and what were people worried there. And one of the guys at Strata in New York said the thing he worries about is the fact that he throws away more than 99% of his data at the collector and doesn't know, what it's for, and as a result, we may be losing the most precious information because we don't know that it's important. And I think, I heard that a transatlantic engine on a 747 in a single transatlantic flight generates a terabyte of data, and obviously there's no way that can be stored. So your point about junk data not being junk, we just don't know it's useful yet, is very well taken. When you see things like protein folding and other tools that are sort of this combination of humans and machines, can you talk for a bit about what you think the future of sort of blended human-machine interaction is for this kind of stuff?
I think it's really important if we're going to be doing more advanced sort of data analysis. I mean, there's not only so much power that humans can have when it comes to doing this on an individual basis or even as a team, but also looking beyond sort of the biases that we come and approach research with. There are certain things that machines will always excel at, and as opposed to humans, and vice versa. So I think it's incredibly important, and some of the examples that we've seen where people have kind of had a little bit more of a playful way of approaching it to get people engaged and also to help the software kind of become a bit more sophisticated as a mechanism of that. I think is something that we'll be seeing more of in the future, but tackling even more difficult problems.
Sure. So a couple of quick questions from the audience, and then we'll move on to some Q&A in the break. Jefferson Braswell asked us how are current developments in semantic web processing as it applies to research and linking data elements and big data, how's that stuff changing research? How much tagging is happening of the metadata and so on, and how's that changing people's ability to collect information?
So we did a lot of semantic web work when I was still at Creative Commons. We had 2 bioinformaticists on staff, and it's really important to be able to show the benefit of having information be machine readable and what you can do to ask harder questions over more complicated data sets and get answers faster. When it comes to the pickup, I mean, a lot of this information, when it was being converted to a digital format, was done so before there was that understanding, or at least not widespread. So we're playing a bit of catch-up, especially sort of in the cheminformatics and bioinformatics communities. They're really leading this sort of cause and the awareness there, but we have yet to see it really take off in the way that it should, because it doesn't have the same sort of user interface, unfortunately, that most would like, and it takes a bit of kind of underground plumbing to get that off the ground. But the linked data movement and some of the awareness that's come about because of that is helping to at least push it to a topic of conversation and something that is a bit more accessible, at least in terms of concept, than it was before.
All right, and one more quick question. Shaquille Mahate, I hope I spelled that right or pronounced that right, mentioned in chat that he hopes that governments and public institutions would ensure none of this data is deleted, but the two examples of CERN and the jet engine, that's a matter of necessity, simply throwing that stuff away. So is there any research on pruning superfluous data to reduce the size of the meaningful data that needs to be stored without throwing away useful stuff?
I'm sure that there actually has been some research that's been done on that. I've been engaged in a number of sort of stakeholder conversations from sort of the government in the UK and also in the US down to the actual institutions. And it is still very heuristic and very artisanal. This gets back to sort of the perception issue more than anything else. I mean, the storage, as you mentioned before, is becoming increasingly trivial and cheap. But there still is this sort of judgment that people are making when it comes to, well, does this matter, does it not, instead of understanding that it's not always their decision to make. Institutions are at least making steps forward, or the right steps. With the NHS, the Prime Minister here in the UK just made an announcement earlier this week about an open data plan for NHS data, of opening up that information, putting it sort of linked data in that same sort of vein. And we've seen steps in the US when it comes to data.gov. So I think that it will be there'll be more examples over the next few years, but we still need to at least increase the awareness about the importance of this information down the road.
Yeah, it does seem like, there's conflicting pressures there. On the one hand, we want the Internet to sort of forget our past and give us some privacy over time, and on the other hand, storing data anonymously allows us to mine it in ways we couldn't anticipate. So it seems like a philosophical discussion as much as it is a technical one.
Yeah, and there's a lot of fear still. So, when it comes to the fear, uncertainty, and doubt, the FUD, we've never faced these problems before. They're very, very new in comparison to the analog world and the history that we're coming from. So, remembering again that we're human at the end of the day, and it's going to take a bit of hand-holding.